Midnite decide to spin up a battery as well. And really, it came down to a couple things. One is that we believed we needed a solution, a UL 9540 solution for energy storage. And having our own battery and our own inverter, we were able to control that and do that in a very elegant way versus having to partner with batteries that may change over time. So this way we control the battery. The other one was we felt we could bring a little bit of our knowledge to the battery industry, and also we just wanted a package. We wanted to be able to offer you something so that when you go out there and roll a truck to the site, you do an install, and if you plug in a Rosie inverter or one of our all-in-one inverters and our battery, if you have a hiccup, you can pick up the phone, you can call our phone number right there on the top of the screen, and you can ask for help, and you're going to get help. If you have XYZ battery and ABC inverter, and you roll a truck out in the field and you're having troubles with the two working together, chances are you're going to go back and forth a little bit before you get that solved out. Whereas, a single name, single phone number, just really wanted to offer you the whole package. So we're going to talk about our Powerflo 5 and our Powerflo 16. So let's go through the specs, and then we'll go talk about everything else. So the Powerflo 5, one of our most common batteries, it is a server rack battery. It is a standard 3U style, so it will fit in any cabinet, like the EG4 cabinet or any of those cabinets that hold a 3U style battery. It has studs on the front instead of the snap-in battery connectors. Something we wanted, was something our customer base was familiar with. But it's 51.2 volts. It is your typical lithium battery, so it is a 16S. It's 100 amp hour capacity. It is lithium iron phosphate, so it is very stable technology compared to some of the other ones. Some of the interesting things we've done is our warranty and our cycle life. So we're claiming 6,000 cycles on this battery, and our warranty is 10 years, and that is not cycle dependent. So that 10 years, at the 10-year mark, we guarantee you 80% capacity or more, or you qualify for warranty. And that's kind of linear anyway through. So let's say at 5 years, you find the battery has 85% capacity, then you're eligible for warranty, and it's prorated based on that. So the warranty is what we feel is pretty strong. We do not count cycles at all, and we'll talk about why a little later, but that cycle life is what we expect. Communications, it does have a CAN bus port. It does have a Modbus port. I'm not sure when we'll get the Modbus port active, but there is an RS-485, RS-232 port that we do plan on making active and offering, some way to communicate with that. The CAN bus is a pylon protocol. So what that means really in a nutshell is that it's a very common protocol. A lot of batteries are speaking that protocol. A lot of inverters will speak that protocol. So what that means for you is that the Midnite Powerflo battery will speak to the Rosie as well as the all-in-one, but also other inverters. If you've got a legacy system with, say, some Victron inverters or what have you, as long as you can set them up to speak pylon, which you can, unlike the Victron or the Solarc, they will talk to these batteries, so you can still do closed loop. But if you're not wanting to do closed loop, you certainly can do open loop as well. And I believe we'll talk about the charging specs a little later, but if we don't, somebody remind me at the end to give you the charging specs. They are printed on the battery, and they are on our website, but that is one of the most common calls we get is, what are the open loop charging specs for this battery? You can stack 8 of these physically, so you'll see the brackets here. They nest together and bolt together, and we recommend no more than 8 high in a physical stack, and then you can stack 16 units in a communications form. So up to 16 batteries plugged together, closed loop to an inverter. You can do more batteries if you need to. We will be at some point releasing a hub to allow you to put stacks together for larger scale systems. But as an example, I worked with a customer the other day on an 18 stack, and the last 2 just don't communicate with the inverter, but you don't really need them to at that point because the amp hour capacity of the battery is such that the inverter is not going to throttle because of those 2 batteries. So what happens in closed loop, just as a quick backup and give you a bit of a oversight, in closed loop, the battery controls the charging. So the first thing it's going to do is it's going to tell the inverter, hey, I am X many amp hours. So that stack you see sitting there of 5 batteries, it would tell the inverter, I'm a 500 amp hour battery bank. I have a, 400 amp charge current limit, and the inverter would program that in. And then it tells it what it wants to charge to and when it wants to stop charging, if you will. So that's what the closed loop really does, is it gives you that control of the inverter from the battery. The inverter no longer has to try to measure the battery voltage through its own terminals and do all the absorb time and all that. The battery takes 100% care of that. And like I said, that communications for closed loop is Pylon protocol. So we do have a CAN bus document, I believe, that we can share if somebody needs it for some reason. But yeah, any common inverter out there today will communicate with these batteries using that protocol. The BMS, we get to ask this question a lot. What is the draw of the BMS? The BMS draws 35 milliamps or less. You're right in that ballpark. Nominal discharge current of 75 amps, peak discharge current of 100 amps on this battery, and nominal charge current of 75 amps. So that's kind of your design criteria, right? Is pick that 75 amps, try to stay that or under, especially on the charging side, right? Like it's nice to charge them fast, but if you're doing a large scale system, then you might want to back that down a little bit just for longevity. They are indoor rated and they are not heated. So the Powerflo 5 is not a heated battery. It is also not actively balanced. It's a passive balanced battery. The PF16 or Powerflo 16 is heated and is actively balanced. The Powerflo 5 is not. That's the main two differences between the two, and the indoor versus outdoor rating. So 3 main differences, I guess, other than the physical size. Temperature in a non-heated environment, 32 degrees to 122 degrees. You can store them below freezing. You just can't charge them below freezing. You can actually even discharge them below freezing. You just can't charge them below freezing. So that's the big thing. Now, we will talk a little bit later about what happens when you try to charge a cold battery, and it's really kind of interesting. So I do want to talk about that, because that is a common question we do get, is why is my charger not charging at its full capacity? And we'll talk about that. Maximum altitude of 9,843, 9,843 feet. You could probably push that a little bit more. That is just the minimum listing that we listed to. The BMS is conformal coded. Everything is fairly safe in there. They are naturally cooled, no fans, and as I mentioned before, 3U rack mounting. So any standard 3U rack. And compliance, UL 1973, 9540A, and 9540. So 9540A is an interesting one. We get asked from time to time for the certification for that. You actually don't. 9540A is not a testing that you get certification for. It's a test requirement for 9540. It's kind of a really weird scenario, but the testing laboratory, UL, ETL, SGS, whoever it may be, will test to 9540A and give you a UL 9540 listing. There are some exceptions to that where you can not do the full 9540A, but you have to put that very clearly on your labeling that you got an exception to 9540. And we will, because we get asked so much, we are actually actively working on getting a statement from SGS or ETL saying that the battery has been tested to 9540A, a lot like UL 3741. It's not necessarily a complete listing, but it's an evaluation that's done by the NERDL. So that's just something to keep in mind. Inspectors have different types of requirements, or think they have different types of requirements, but there is no actual like ATM authorization to mark, if you will, for 9540A. So let's jump over to the Powerflo 16. Same nominal voltage, same number of cells in series, 16S. They are just bigger cells. Both batteries use a grade A plus EVE cell. Both have our own modified BMSs in them from the original ODM. And we'll talk more about the BMS a little later. The 16K or 16, Powerflo 16 is 314 amp hour, 16.076 kilowatt hour. Again, lithium iron phosphate. Now the 16 is rated for 8,000 cycles, and that's got something to do with a little bit more of the active balancing and some of the stuff we've done on the BMS on this battery being a little, more of a higher end battery, I guess, if you would. So 8,000 cycles, 15-year prorated warranty. So again, what that means is at the 15-year mark, we're guaranteeing you that battery will have 80% of its capacity that it had when it was new. What that also means is at the 7.5-year mark, we're guaranteeing it'll have 90%, if you will. So if you draw that line, you can kind of extrapolate the capacity over time. And again, it's nothing to do with the cycles. It's solely based on time. Another question we get a lot is, what does the heater draw in this unit? So the heater draws around 300 watts. It turns on around 2 degrees C and it turns off around 10 degrees C. Now, I apologize, I do not have that correlated to Fahrenheit. I believe we do on a slide coming up, so hold on for that one. Don't put that one in the question pane just yet for me. The heater only runs off in charge current, though. So when you're basing and sizing that system, you size the solar array to run that heater when it's charging. But when the sun goes down at night, the heater's shut off. Because remember, we can discharge the battery when it's cold. We just cannot charge the battery. Now, that does bring up another topic, which is derating of the charge current based on temperature. And again, I have a slide coming right up, but we'll talk about that. But that is something to keep in mind. Now I was even asked this question, or I asked this question early days, like, does the heater just run all night and drain the battery down? Well, it turns out, what the answer was, no, the heater only runs when there's charge current available to run the heater. So if you have 300 watts of PV and the battery's setting at, 10 degrees below zero, then the heater is going to run and all that PV is going to run the heater. Nothing's going to go into the battery. If you have 500 watts, then 300 will go into the heater and 200 will go into the battery, so on and so forth. Again, same communications, CAN bus, RS-45, RS-232. Also the same comms. You can stack up to 16 units. These batteries are either wall mount or floor mount instead of, rack mount. So you can actually set them on the floor or you can mount them on the wall. There is a spacing requirement. We say 12 inches. Some places will make you go up to 3 feet depending on, all the listings. I think some of the California requirements are pushing you out to like 3 feet of spacing. So definitely, know your requirements there from the AHJ. Nominal discharge current of 160 amps and a nominal charge current of 160 amps. The maximum discharge is 210 amps. So we do say you can use one of these with one of our all-in-ones. Under the exact right conditions, you can overload a single battery. So again, if you're designing the system such that the customer is going to be hitting that all-in-one inverter with a 12, 14 kilowatt load now and then you probably need more than one battery. If the customer's only got, for a 5,000 watts of load that they may ever run, but you predominantly want to sell to the grid and have a little bit of backup, then one battery is fine. So just kind of keep that in mind when you're sizing that system, is that 160 amp area is kind of where you want to be. You don't always want to be pushing it to 210 all the time. I did say outdoor rated IP65. We do rate this one down to -4 degrees Fahrenheit with the heaters, and storage again down to 14 degrees Fahrenheit, which sounds kind of weird that you can, set it outside at -4, but you can only store it at 14. But that's got to do with the heaters. Same altitude requirements or listings, if you will. Again, no fans, but it does have active balancing. So it does have all the same listings. Everything else is the same. The big things, I guess, if I was going to go back and recap this, is the differential between the two is active balancing. This does have fire suppression, which I didn't see a bullet point for that, but the 16 does have internal fire suppression, and it does have, the outdoor rating. So there's a few differences there that set it apart. Most predominantly being the active balancing, and that's how we get the extra 5 years on the warranty. I am being asked if they're available on Solar Assistant, and yes, you can talk to these batteries with Solar Assistant. They're not listed as Midnite Powerflo, but you can pick any battery in there that speaks the pylon protocol, and they will work. We have played with that some, and I do believe that we'll be getting the Midnite name actually added to. We're actively working with Solar Assistant on a lot of stuff right now. The Rosie, the batteries, the all-in-one actually works on Solar Assistant under a different name. So there's a lot of stuff going on there that we should be getting some new firmware very soon from Solar Assistant. So this is a slide that got put in here. Why lithium iron phosphate? And this is really comparing it to flooded lead acid. So, I was a long time off-grid guy, lead acid guy. That's all I would use. Didn't know anything different. Didn't want to know anything different. And it was hard for me to make that switch. And for me, the switch was made kind of because a manufacturer gave me some lithium batteries to test. They wanted me to, you know, play with them, test them, run them in an off-grid scenario, and give them feedback. So I'm like, this is a perfect opportunity for me to get my feet wet in lithium. And as I did that, I realized that they're really, really efficient. And what I mean by that is, like, I struggle with the good analogy, but like if you was to take 20 feet of garden hose and hang it straight up in the air and try to blow water up through it, you'd have a hard time and you wouldn't get any water out the other end. If you laid the hose down on the ground and you blew through it, the water comes out real well. And that's sort of the analogy I use for like lead acid versus lithium. When you've got a lead acid battery, it takes a certain amount of energy just to push against that battery for that battery to even accept current. Whereas like with a lithium battery, it seems to accept anything you give it. So, to summarize that in something maybe simpler is if you live off grid and you've got a cloudy, snowy, rainy day and you're seeing 400 or 500 watts on your charge controller, if you've got a lead acid battery, that 400 or 500 watts really isn't doing anything. It's just pushing, but nothing's being pushed into the battery. With the lithium battery, that 400 or 500 watts seems to mostly all go into the battery and really, really does work well. And the capacity issue is the next one, right? Like if you've got a lead acid battery that says it's 100 amp hours, you've been told and told and told, never use more than 50 amp hours out of it. But in reality, you're probably only getting 30 amp hours to get down to 50% after the battery's used for a little while. There's a lot of capacity issue there. There's also the issue of sulfation and stuff with lead acid batteries, where you leave them at a partial state of charge. They just do not like that. That will kill a lead acid battery quicker than anything. I've ruined plenty of lead acid batteries myself. I've got several hundred installs out there with customers, and I always told my customers, the very first thing I told them was, let's get you an inexpensive set of lead acid batteries so you can learn how to live off grid on your brand new system. And in a few years, we can upgrade you to something nice, but let's not spend the money on something nice right now, because you need to learn how to treat these batteries. And generally speaking, every new off-grid customer kills their first set of batteries. So, you get a cheaper education by using a lesser expensive set. But now with lithium, much less of an issue, right? We can throw them in there. Everything works. We don't care if they set at a partial state of charge for an extended period of time. Life is good. So, and energy density is another one, right? Like if you're doing something where your weight is an issue or space is an issue, lithium is going to be your friend. If you're doing an RV or a tiny house, or you just have small amount of space, lithium is much more friendly. So, there's several reasons to do it. I could compare it against a bunch of other lithium batteries as well. I think the big thing that sets us apart, and I'm going to talk about that on an upcoming slide, is how we manage the charge current based on state of charge and temperature, and how we give you that warranty without cycle count. So I do have a couple questions. What data can be read off the MNGP2 in a closed loop communication? So currently the newest code we've got out for the MNGP2 allows you to see the basics of the battery: state of charge, temperature, state of health, the generic stuff you'd see, current in and out of the battery and all that. And then there's a second screen that gives you a lot more detail about the battery, as well as all faults and warnings. So you see the battery as a sum. If you've got, say, 10 Powerflo 5s and you plug them in, you're going to see that as a singular 1,000 amp hour battery, not 10 individual batteries. That's where Solar Assistant really comes in nice. With Solar Assistant, you can get down in the weeds with with every individual battery, and I'm going to take a little bit of a tangent, and I'll show you what that looks like. So this is something like what you might see on Solar Assistant, where you can get every battery individually. You can get a graph over here showing each battery, side by side, your highest and your lowest, and your average cell voltages. Just you can really go kind of wild with the Solar Assistant part of it. But on the MNGP2, you get all the basic functionality. You get the communications, the lost packets, and any faults and warnings, and all of that good stuff. And I mean, Canada didn't even know it will not be used in the world. It'll be stored at around negative 20 C. What will happen? That's a good question, and I don't have a really good answer for that one yet. I would say shoot us an email, support@midnitesolar.com. I think it will be okay, but I would like to verify that with engineering before I offer you an actual yes or no on that question. What is the recommended PV charge current for a PF16 when running off grid? So I'm going to talk a little bit about maximum charge current, I believe, on the next slide. I would say there is, when it comes to recommendations, I would stick by the 10 to 15% rule as a minimum. Like I always size the system at a 10% charge current on a lead acid battery. I would say that mentality can still hold true with the lithium as your base, if you will, your minimum charge current. So 300 amp hour battery, let's make sure we give it at least 30 amps charge current. But we can go all the way up to, a lot more than that, which we'll talk about on the next slide. Or the slide after that, but it's coming right up anyways. If Chinese trade war shuts off access to new units and repair parts, is Midnite prepared to onshore the manufacturing? That's a good question. Yeah, we would be prepared to do that if that happened. I don't see the trade war shutting access off, but I don't have a crystal ball. So I'm optimistic it won't, but if it did, then yes, we would do what we have to do to keep going, for sure. So we could have a whole webinar about trade wars, but we won't go there. So some more about lithium iron phosphate. Those of you that don't know, I'm not going to go into the science of it, but lithium iron phosphate tends to be more stable than some of the other lithium chemistries out there. There's an explanation there of why, but just know that it is safe. It has been tested. The 9540A testing is amazing. They actually intentionally fail batteries, try to catch them on fire, and you have to put a piece of cheesecloth over the whole assembly while you're doing this test. And if that cheesecloth ignites, you fail the test. So it's very very safe when you get down to it. The testing is pretty intense, and if anybody's ever played with cheesecloth, you know that it takes almost nothing to light that on fire. So that's the kind of testing it has to go through. There's some stuff on the internet about the testing you could find that other manufacturers have done of 9540A, and the brutality of that test of those batteries is amazing. I would say for me, everybody's like, I don't want to have lithium in my house. Lithium scares me. I'm afraid of lithium fires. I've seen a lot of lead acid fires. Personally, I've seen a lot of people install multiple strings of lead acid batteries. One has a short internally, the other one's getting up on it. Stuff catches on fire. I've seen cold flow on the lead terminals, loose connections, things arc, burn. We were in a fire investigation on a residence that had a battery fire in a crawl space with some of our equipment in the system, and that one was just that. There was a cold flow on the lead terminal, and the cable got loose, and the backup generator came on because it was snowing, which then hit at the full capacity of the battery-based inverter, and that basically caught that battery on fire from the high resistance connection. And it was a lot of black soot, a lot of dust and damage. So I think when it comes down to it, the moral of the story is if anything is installed correctly, the risk is very minimal. If anything is installed incorrectly, the risk goes up exponentially. So there's a risk with anything. Doesn't matter if it's an oil lamp versus an electric lamp versus a battery. There's a certain amount of risk we accept every day in life, and I would say that for me, the lithium batteries are probably just as stable in my mind as a lead acid battery. Really, the lithium iron phosphate. I'm gonna put that out there. So, long-winded as I am, why the Midnite brand? Why our battery, not somebody else's? Well, I think I kind of already covered that, but really, you get single point tech support when you have an issue. The two are made by the same company. They're made to talk to each other. Simple things like if you've got an all-in-one inverter, you can do a firmware upgrade to the Powerflo battery directly through the inverter. Certain things like that to make it a little nicer for you. Quality BMS. I've always told people, hey, when you're buying a lithium battery, you're buying two things. You're buying a lithium battery cell, and you're buying a BMS. Everything else is really packaging. I mean, there is workmanship in there, but it's really packaging. So if you're getting a grade A plus cell, and then you got to get a good BMS. So we've put a lot of work into this BMS with our ODM. We've added a lot of functionality that, again, is on the next slide. Warranty and technical support based right in the U.S. The batteries are, in Washington. The spare parts will be here next week for the all-in-one inverters, and I think the batteries. So moving forward, we'll be able to do, BMS swaps if that's easier than swapping a battery, things like that. And then just our industry presence. I mean, we're a name that's been here for a long time, and if you know the name, it's a lot longer than 20 years because we've been here before. Midnite, we were out back, and then we were Trace. So we're not new to the industry, right? Like a lot of people are. And then how do we accomplish closed loop with the SolarArc? Is now they do not support this battery. So that's kind of a loaded question. You can close loop at the SolarArc just absolutely fine, not a problem at all. I've done it. We've got many customers doing it. SolarArc actually came out, to my understanding, and I'm speaking a little bit from hypothetical because I could not get a straight answer out of the guy at the show, but I understood that what really started the fire was EG4, and they came out with the statement that if you closed loop with the EG4 battery, they were going to deny you warranty on the SolarArc inverter. I actually went and talked to the sales guy for SolarArc at that same show because my particular system at the time was EG4s and SolarArcs. And he couldn't really give me an answer, but he kind of said, well, we don't know what the battery's going to do to us, and yada, yada, yada. So there's really nothing that a battery can do to damage an inverter through a CAN bus cable, which is all you're doing when you close the loop. It really comes down to, though, how you feel, what's going to happen, right? Like if you install that system for the customer and you wire it up, and then SolarArc is like, hey, that's not a supported battery, that's kind of unfortunately on you, but that is what it is. And the question is, do we build a custom cable? You probably don't need to. In my experience, a straight through Ethernet cable, just a regular Ethernet cable, works just fine. The cable that comes with the battery should work just fine. The industry is sort of standardized on the 2 pins for CAN bus for battery comms and closed loop. So I have not had to make a custom cable for the SolarArc. I will say that on the Rosie, and this is on the Rosie system, you want to use a 2-wire cable using pins 4 and 5. The batteries come with a 2-wire cable that has inverter on one end and battery on the other. I have got some reports of some Powerflo 16s shipping with 8-conductor cables. And if you use the 8-conductor cable with the Rosie, you end up shorting out the Rosie's stacking bus internally. So you can cause some issues. There's no damage will be done, but the Rosie won't behave correctly. So if you're using this on a Rosie system, 2-wire cable using pins 4 and 5 should be included with the battery, but if you got to make a longer one, just pins 4 and 5. All right, let's see if I can find this slide I keep referencing. Here we go. Here's the meat and potatoes of the charging. So this is going to be a lot to take in. This will be recorded. We will publish it later. But what I really want to call your attention to is a couple things. This chart right up here that says charging parameters, and I think you guys can see my mouse. This is missing a little part up here that is 0 to 10%. So it should be 0 to 10, 10 to 90, 90 to 100. So if the battery is below 10%, the battery will limit itself to 0.1 to 0.2 C charge rate based on the temperature. If the battery is between 10% and 90%, this is your charge rate based on cell temperature. So you can see if you're in the normal window here, you're going to have a 1C charge rate. And if the battery is above 90%, we throttle the charge current back again. So this is how we give you that 10 and that 15-year warranty. Is we limit how hard you can hit that battery when it's completely empty or completely full. In the middle, game on, you can hit it at full 1C, right? But when it's real low or real full, we throttle that current back to minimize, any damage to the cells. And we also throttle that back based on temperature. So this is another one. Customer will call and say, hey, it's 15 degrees Fahrenheit out, and for some reason my battery is only charging at 1,000 watts instead of 10,000 watts. And that's this temperature derating here. If the heater is on, or if you've got a Powerflo 5 that doesn't have a heater, at 32 degrees or less, we don't charge without the heater. We charge with the heater, of course. But if the cell temperature is below 32, we turn the heaters on, but we do not start charging until we get to 32. And between 32 and 41 degrees Fahrenheit cell temperature, now this is internal in the battery, we charge at a 0.1 C. 41 to 59, it's 0.5 C, which is starting to get pretty stout. And then, like I said, in the window here, it's a full 1 C. So that's something that if you see that, like, why is my battery at 95% and I'm only charging it, 1,000 watts instead of 10,000 watts? Well, that's because the battery is close to full and we're throttling back to keep those high cells from getting too high. That's just what we do. That's one of the things that we spun into the BMS to sort of give that longer warranty without any cycle life. So that's something, this is an important thing to keep in mind. Discharging is different, but a little similar. If it's below -4 cell temperature or -13 inside the battery, we'll shut off and throw an alarm, and it will recover when it gets up to 0 degrees Fahrenheit. So discharging is not as finicky as charging on a lithium battery for sure. But this is an important chart to, get your hand on. I can email it to anybody that wants it if they want to shoot me an email. This is just something that's good to have. Question is, given the volume and the density, how long would it take to heat the battery using a 300 watt heater from 10 degrees, -10 C to +10 C in a -10 C environment? That's a really good question. I don't have that information right in front of me, but if you want to shoot me an email, I can certainly get you the calculations for that. I'd have to get up at Logan and get that, but that is a good question. So shoot that in an email, and I will try to get that added to my slide for the next time we do this. So moving on, here's another thing that we run into is operation of the battery. So I want to talk a little bit about how do you wire it, how do you operate it, right? So how we do that is what we're going to talk about. But there are some steps to turning things on. There are some things to remember. There's a power button on every battery, but we only want to use one power button, and that's on the master battery. And we'll tell you how to find the master battery here in a minute when we show you the wiring. The SOC LEDs will only show up on the master battery as well. So again, important to know which one's your master, right? How to bring the system online. Switch the breaker on the battery on, press and hold the battery's power button until the run light comes on, and then switch your inverter on. And then if you've got an all-in-one, you hold the button on the side until it beeps and it turns on. If you got a Rosie, it's already on because it turns on by default when you apply DC power. And then you switch on the circuit breakers on the inverter's load side to power your loads, and then the grid, etc. So kind of the startup sequence. Here's what I was talking about the power button though. If you have, say you've got 5 of these Powerflo 5s and you decide to press the power button on all 5 batteries, what you're doing is you're shutting off the slave batteries by pressing the power button, because when you turn on the when you press the button on the master battery, you turn on all 5 batteries. And then when you go down through and you shut off the other 4, you think you're turning them on, but you're actually shutting them off. So remember, one button. Just push the button on the master battery and that's it. So here's your jacks. Here's what this looks like wired up with the 3-stack over here to an all-in-one. But this one right here is what you're really focusing on. You've got a linked in, a linked out, and a BMS or CAN port right here. It's labeled CAN. CAN is your closed loop communications to your inverter, is shown up here with this blue cable. Linked in and linked out. So you go from the first batteries linked out, so out of battery number 1, to in on battery number 2, out of battery number 2 to in on battery number 3. And the way the system comes up with master is the one with nothing on the linked in port. So as you can see here on this top battery, that linked in port is empty. So the BMS automatically assigns that one as the master, and everybody else becomes slaves to that battery. So there are no dip switches, no programming. It's all automatic. But that one battery, that's how it determines who is the master. So when you're in doubt, you look down like which battery has the empty upper corner port linked in. That is your master. That's the one you push the power button on, only that battery. And if you're running open loop, you still connect the link in, linked out together like this down here, and you still press the one button. You just don't have the closed loop. Now, something about closed loop that I'm going to point out, a little off track here, but this just came to my mind and we don't have a slide for it. You'll hear me say it's all automatic. There's nothing to do. And that is true. If you plug the battery into the all-in-one or you plug the battery into the Rosie, the system just works. It knows what to do. It's told what to do. Everything works, flawlessly until it doesn't. That's another story. But if like a mouse chews through the CAN bus cable or something like that and you lose comms, what happens is a little bit different on all sorts of inverters, right? So like the all-in-one, for example, if it loses communication with the battery, it shuts down and it throws a battery communications error. The Rosie, if it loses communications with the battery, it reverts back to its programming. A Solarc, if you will, has both available. If you check the box to defeat the UL requirement for the grid tie inverter, it will actually stay running and revert back to its open loop programming. So that being said, if you're using a Rosie, and I'm going to speak predominantly to Midnite inverters here, if you're using a Rosie, I really, really recommend that you program your charge settings properly for the battery. It's a couple more steps, but I really recommend you do that because if there is ever an issue and that cable gets chewed through or whatever reason that comms is lost, the Rosie will just keep her on running flawlessly with no problem. It'll just go to open loop instead of closed loop. So, that's something important to know. I just wanted to throw that out there while we're talking about that. And please forward your email address. So super easy, ryan@midnitesolar.com or support@midnitesolar.com. Either one of those will get to me and we'll get your questions answered. Again, that's ryan@midnitesolar.com. And what are the ideal charging parameters? Is it true that running a life battery from, say, 30 to 70 SCC will increase its longevity lifespan versus running from, say, 10 to 90? Is it possible to program the IO to prevent charging greater than 90 or use any other method to treat the battery in a way that maximizes its longevity? So we believe with the algorithm I showed you just a little bit ago, by throttling back on that upper 10%, we're not worried about the 90 to 100. Our recommendation is you stay above 20%. We believe that anything lower than 20%, you're starting to degrade the cells more rapidly than you would if you stayed above that. We're not really worried about the 90 to 100. So yes, if you could stay 20 to 30% state of charge to that 100% state of charge, you're going to extend the life of that battery to the most you possibly could. And can you have 2 stacks of 4 and wire them in parallel? You sure could. Yeah, I mean it's a lot based on what you've got to pull for charge current or discharge current, if you will. So let's say you're doing a single Rosie and a single Classic 150. You know that the most the Rosie can charge at is 120 amps. The Classic's about 100 amps. So absolute most you could do is 200 amps discharge current, and discharge current is about 250 amps on the Rosie. So then you'd look at it and say, okay, if I need to do 8 Powerflo 5s, can I do 4 in one stack and 4 in another, and then bring those two together? You can certainly do that. So the wiring really comes down to how you're going to be drawing current and wire size. Like this picture here, these could all be small gauge wires going to this combiner. So these could be, say, number 2 wires, and then you could have a 2-aught or a 4-aught cable going to the actual inverter. If you daisy chain these together, now all your cables have to be the larger size, right? Like if you say stack 4 of these up, ran them to this combiner, stack 4 of them up, ran to this combiner, now each stack is delivering half the power. So that's sort of what you got to look at is how is the power being divided out around. I personally like using like our lithium battery combiner and running each battery back to the combiner, but sometimes that's not practical, so you've got to do what you've got to do when it comes to that. I will say that on a actively balanced battery, cable lengths are less critical than on a passively balanced battery. So in this installation, I would try to make all of my negatives one length and all my positives one length. They don't have to be the same as each other, but they should all be the same. And what you're trying to do is keep the resistance of the whole circuit the same. And Powerflo 16, that's more forgiving because the batteries will actually tell each other to take the current and balance out over time, over time when you're charging. Battery positive and negative connections, daisy chain using large enough conductors versus combiner box. Yeah, so I kind of just hit on that, but that's really what it boils down to, right? Like if you've got 8 batteries in a single stack and you wanted to run, say, 4-aught cable between every battery, and you pull the inverter negative off the top battery and the inverter positive off the bottom battery, that's going to work, but the middle batteries are going to lag behind a little bit in both directions. Whereas if you run all 8 batteries, using, say, number 4 wire to a lithium battery combiner, and then you run your cables, they all get the same amount of current. So to me, daisy chaining the batteries, it's kind of it works in a small scale, but as the system gets larger, I try not to do that. So you just got to balance what works the best for you. If you're using a cabinet similar to like the EG4 that has bus bars in it, and you put 6 batteries in it, you can bring your inverter terminals out of the middle of that bus bar. Then you're really only crossing 3 batteries each direction. That works really well. So again, it's just really just figuring out what fits your needs and what's going to carry the ampacity the best, and keeping in mind that if the customer does something weird, like shuts off these 3 batteries in a stack of 3 over here is going over a small cable, now is it carrying too much current? So there's a few caveats here to think about. Yeah, so I've got that question in many different ways. Like, are you obligated to use a battery combiner, or can you link them together? You certainly can link them together. It truly is again up to you and what works to carry the current. If you're doing, say, 4 all-in-ones and you're going to have a whole pile of these batteries, then I'm going to say you'd be way better paid to get battery combiner, bring stuff together, combine it, and decombine it to the inverters. If you're doing a single Rosie and 5 of these, then maybe daisy chaining them together is perfectly fine for that. Does the Powerflo 16 communicate with Classics? It does not at this time. The Classic is Modbus. There is no communications between that. It would if the Rosie, of course, in that case, but not with the Classic. Now that being said, the Powerflo will still limit current for charging based on all those parameters I showed you, even in open loop. So closed loop is not a necessity by any means. It's kind of nice because it puts everything into a single page, and it takes out user error. It eliminates some programming, and so on and so forth. But it's certainly not a necessity. There are just piles and piles of open loop lithium battery installs out there running perfectly every day. And question, what if we use bus bars to connect the 4? So what they're asking is, could they run a copper bus bar up across the air? You certainly could. or if it was in a cabinet, like an EG4 cabinet over here. Yeah, you could certainly do that. That's totally up to you, and then you could run one set of large cables. If you're going to daisy chain a stack of batteries, though, I do recommend pulling cross corners or out of the middle. Like in this stack, you could pull across the corners, you could pull off the middle battery, to go up here. So just kind of keep that in mind. Don't pull off the same battery. So if you got 8 of these stacked up, don't pull off just the top battery because the bottom one will lag way behind. Any ideas about recycling LFP batteries? Seems like that's a can of worms that's being kicked down the road. That is a good question. I don't have an answer to that. That is Logan's arena. Again, if you want to email me, I could certainly get you our policy on recycling them. The server rack spec for the batteries was 3U. So a server rack is rated in what they call U's. U is in uniform, and you have one U, 2U, 3U, 4U example. So all these server rack batteries like this at EG4 are a standard 3U, and yes, they do fit in the EG4 cabinets. All right, so let's go on to the Powerflo 16. So it's a little different. It has the breaker on the side and the power button on the side. Same idea. Turn the breaker on first, press the power button, then turn on the inverter's power button. Pre-charge is pretty stout on this battery. I can start an all-in-one and or a Rosie off of a single Powerflo 5, and I do no pre-charging. It's all sort of built into the battery, if you will. It soft starts it. So yeah, the pre-charge is very stout. And there's a question whether Midnite plans to offer cabinets for the PF5 battery. And yes, that is in the works. I know that Logan had said he had some stuff in the works for early in 2025. I will have to, get some updates on that. But do rattle our cage on that if it's something you're looking for, and we can tell you where we're at. How deeply are the temperature probes embedded in the stack of the PF16? Oh, in the 16. I think you mean the PF16. And is there an algorithm to estimate the individual cell temperature in core? Darn good question. I don't have an answer to that one. There are several teardown videos on YouTube already. I can't remember the guy's name that did the best one, but certainly you could email us. We can try to get engineering to answer that question, and or we can point you to those videos. So communications on the PF16 is the same, but a little bit different. One thing I've left as a mistake in here, and I left it in here intentionally because it's in the manual, and we're working to get that manual corrected. But just like I said on the other battery, linked in, linked out, linked in, linked out, linked in, linked out. The battery with an empty linked in port is the master battery and must have the closed loop CAN cable. So as shown in the manual, if you wired this up, you would not get closed loop communication with your inverter. This cable right here is incorrectly drawn, and we're fixing that as we speak. That should be plugged in over here. So keep that in mind. The battery with nothing in the linked in port, and I'm going to stress this a million times through this presentation, but the battery with the linked in port empty is your master battery. It is the one that you press the power button on. It is the one you see the state of charge on, and it is the one that you plug your closed loop into. So I'm going to drive that home a few times because that error in the manual, it's unfortunate, but we are working to get that fixed. Same kind of mentality, right? Everything's off. All breakers are off. You plug your link in to link out cables down through your stack of batteries. You plug in your closed loop cables like you normally would. No programming needed. And then when you're ready to turn it on, same process. You turn the breakers on, press the power button on the master battery, and then you go ahead and turn your inverter on. So I'm going to transition a little bit into some kits, and then we're going to ask more questions. We have now actually offered some more affordable kits of pre-wired systems with bundled with the batteries. So like for example, you can get a Rosie pre-wired with 4 Powerflo 5s or 1 Powerflo 16. You can get additional batteries. You can get lower cost classics, Hux Bays, or battery combiners bundled with that. So there's there's certainly some financial benefit to doing that as a package, if you will. So definitely reach out to sales or myself and ask about this. But that's something new that we started and is gaining a lot of popularity. I'm not going to go over all the specs of the battery again because we did go over that. Just know that the kit with the MN Rosie PW-5-kit comes with 4 Powerflo 5s, and the MN Rosie PW-16-kit comes with 1 Powerflo 16. So you can pick your kit based on the battery you want, and you can add to the bundle down here and just expand what you need. If you need 2 Rosies, we can do a master and a slave, or we call it primary and follower on the Rosie. We can do that. There's a lot of flexibility in these kits, so that's something new. We're really excited about packaging stuff together and offering you a simpler solution. And again, don't forget to add the accessories. I'm not going to spend a lot of time going down in the weeds. Just know that we have battery combiners to fit virtually any need. We have 250 amp, 500 amp, 1000 amp, and 2000 amp. So we've got some pretty stout battery combiners. And we have PV combiners from mild to wild. So we have 3-string, 300 volt. We have 10-string, 1000 volt. There's a lot of variations in there. So if there's something you need, we have disconnecting, we have non-disconnecting, we have fused, we have breakers. And with the new breakers that we have now, we have 300 volts in a 1/2 inch wide pole. We have 600 volts in a 1 inch wide, 2 poles, each being 1/2 inch. So there's a lot of flexibility. All of a sudden, something like a PV6 Disco now becomes a 3-string 600 volt disconnecting combiner. So if you've got to run 3 strings to your all-in-one, you can run them through that 600 volt breaker 3 times, 3 strings, and you got a single disconnect for that now. A lot of cool things there. Just keep that in mind. So I've already got a bunch of questions, but go ahead and type your questions in, and we'll get through these. Adam DeLay is a gentleman on YouTube that does all the good teardown videos. That is right, Adam DeLay. If you just search for Midnite Powerflo teardown, you're probably going to get his video first. Powerflo 5, let's say I have 2 stacks of 4. Can I connect each stack with the provided 2-conductor long wire, or do I need an 8-conductor? So the 2 stacks would need to be connected together through the linked in and linked out. So if we go back here, you have your linked in and linked out ports here. So say this is stack 1 and this is stack 2. The provided cable isn't long enough to go from linked in to linked out anymore. You need to supply a longer 8-conductor Cat5 cable to go from your linked in of stack 1 to linked out of stack 2, if you will, and continue that. So all batteries have to be link in, link out, link in, link out, and then 1 CAN bus cable for closed loop from the master battery. I recently purchased 2 Powerflo 16s. Do I need to install new firmware? So how do I go about that? You probably don't. So there hasn't been a lot of firmware changes or additions, if you will. I know there's something to do on the Powerflo 16 with the heater operation that has changed a little bit in firmware. So if you're using it in a cold environment, you might want to reach out to support, and we can tell you how to go forth with that. But just in general, there's no. We don't necessarily advocate always updating firmware. Like some people are always like update, update, update. My general philosophy is the system is operating the way I want it to, and it's functioning with the features I want. I sort of leave it alone. If you're getting to the point where, hey, there's a feature I really want, or there's a bug that I'm dealing with, then yes, we can update firmware. It can be done through the all-in-one inverter, or we can send you a programmer, and you can flash the batteries and send us the programmer back. And speaking of Adam Delay, he does chime in and say the temperature sensors on the PF16 are on top of the cell bus bars. Thank you for that. If I start an AIO with one Powerflo 16, can I add one, say 2 years later? Will that work okay? Is the same with the PF5 batteries. So generally speaking, the answer is yes. You can mix ages of lithium batteries. What you're going to find, and if I can find this, right here and pull this back over here for a minute, not that. Oh, bear with me. Technology is my friend. This stack of batteries is actually 6 batteries, and they're a year apart. So you're going to see these things called state of health. And you'll notice this one is 99, this one's 99.2, this one's 99.5. So obviously the batteries wear out as they age, and if you waited 2 years, that one battery has 2 years out of its life, and it's going to wear out before the new one, and that starts a cyclic. But yes, you can certainly add to it over time. And what is the minimum number of kits that can be ordered for purchase? We sell them one at a time through distribution, so I would believe that the distributor would honor that as a single kit, if you will. So there should be no MOQ on that. I'm asked if I can go over the pinout requirements you mentioned for the comms cable pinouts for the Rosie. So I certainly can. I don't have an example cable readily at my fingertips, but a Cat5 cable. Let me just find something real quick. So let me see if I can make this picture a little bigger. So that's a standard Cat5 cable. It'll be orange and white, orange, green and white, blue, blue and white, green, brown and white, and brown. The batteries and inverter use pins 4 and 5. So they use the blue and white wire. So if you had to make your own, just only populate pins 4 and 5. Again, they do come with the battery, but if you had to make your own for whatever reason, just do pin 4 and 5. Take your other, and the colors don't really matter so much in this case because we're only using the 2 wires, but the colors are actually twisted together in pairs inside a cable. If you've ever cut apart a Cat5 cable, the orange and white are twisted, the green and white are twisted, and that's the comms, if you will. So one color is one, one color is another. But yes, definitely, if you're making your own cable, 2 wires, pins 4 and 5 only. If you have to buy an 8-conductor cable for some reason, because you don't have a crimp tool, you can, be kind of down and dirty, and you can cut the jacket off the cable back here, and you can cut the other, 6 wires and tape it back up. But that's kind of down and dirty, right? Like crimpers and connectors are pretty affordable, something you should have in your toolbox. Just go ahead and make a cable. Yeah, and as far as mixing batteries on age, I don't have an actual, hard line in the sand for you, right? You have to make that decision. If you have a battery that's say 5 years old and you add a brand new battery to it, that battery that's 5 years old, it has a 10-year warranty. If it wears out in 10 years, the other battery is now 5 years old. So at some point, there's a return on investment where you may say, okay, we're 7 years into a 10-year battery. Instead of adding 4 more batteries to that system, maybe we should buy 8 batteries and sell those on the used market or something. So you certainly have to balance that. I don't have a hard line in the sand that says after this age, do not do it. But there's a financial reason not to do it after a certain period of time, right? Like you're you could get down the road, say in that 10-year mark, and then you can't get a compatible battery, and you're changing the whole battery bank when batteries are only 5 years old. So it really just boils down to what makes financial sense. Can we make a longer cable between the Rosie and MNGP2? I'm not sure if that question is asking me if you can move the MNGP2 farther from the Rosie, because you reference a 4 and 5 pin cable. But either way, the MNGP2 can be moved away from the Rosie system with Cat5 cable. I've gone 150 feet with no problem using an 8-conductor Cat5 cable. If you're talking about the communications cable for closed loop, I think that could be fairly long, but generally speaking, your batteries are really close to the inverter anyways. So I'm not sure exactly what the question was there, but yes, if you're looking for a off-the-shelf 50-foot Cat5 cable to move your MNGP2 farther away, Amazon is your friend. Probably be here tomorrow, depending on where you live. Considering making a little Rosie PF5 kit for a much more robust solar generator type backup power versus Anchor, etc. There's a Diamond does it now. Midnite likely would be much better quality alternative. It would be a nice entry product to expand the Midnite client base. Yes, we didn't talk about the Little Rosie here. The Little Rosie has been released as a mobile inverter, and I expect some variant of it to be released as a renewable energy very, very, very soon. And we will be doing some major promotions with that when that hits the market. We're super excited about the Little Rosie. Very lightweight, very powerhouse. Those of you that are familiar with RVs and starting RV air conditioners, our main mobile distributor in Elkhart, Indiana, has a display in his showroom where he has a Little Rosie and two 15,000 BTU rooftop air conditioners, and he could start them both cold from the Little Rosie at the same time. Just standard RV air conditioners, nothing special done to them. So you'll definitely see something on that in the very near future. Replacing a lead-acid battery bank on a Snyder SW 4024 with two 4-battery stacks of PF5 paralleled batteries. Is wiring communications between each battery useful, even though there's no communications with the inverter? So first thing I'm going to say is you cannot use a 48-volt battery on a 4024 inverter. So I'm hoping that was a typo on the inverter, because that's a 24-volt inverter. But if the base question, if you're in an open loop situation, is there really any reason to hook the linked in, linked out cables together on the PF5s? And yeah, not so much unless there's a really unless there's really a fault, some big fault, then the batteries can tell each other to shut off. Or if you just want the convenience of turning one battery on. In the Powerflo 16, you have the active balancing. They're actually telling each other to take current, don't take current, to balance everybody out. So in that application, it's not completely necessary. But we give you the cables, so why not? Is there a black start white paper for the PF5 and PF16? No white paper per se. You simply apply voltage to them. So either one of those batteries, if you run it down past BMS shutdown, you turn a charger on that has voltage present, and the inverter, the battery will black start. I do believe you can do something with the power button and possibly get so many seconds of power to light up a charger, but I haven't played with that. I will do that, and like I said, send me an email like the other questions, and I will act on that. What is the fire suppression system in the PF16s? So I probably can't find an example of it real quickly, but I think Adam actually shows it fairly well in some of his videos. But in a lithium battery, there's a little box, if you will, a little plastic box or something with stuff in it, and then there's a hose that goes around the battery. And if there's a fire in that battery or it gets hot, that pushes that chemical out through that hose and suppresses the fire. It's pretty common in a lot of lithium batteries. So if you just get on YouTube and search for fire suppression lithium battery, you'll find a lot of probably bad videos, but you'll find some with the fire suppression as well. But again, I'd highly recommend hunting out Adam DeLay's YouTube channel. A lot of great videos on the Powerflo 16 and the other equipment. But yeah, it's a pretty simple system in there, but it's just made to release a chemical to stop the thermal runaway and prevent anything from exiting the box, if you will. Charge voltage settings using a classic 150. They're on the website. They're on the battery, but it's 56.1 for absorb, 5 minutes of absorb time, and 54 volts for float. I will tell you, if you're going from a lead acid battery on anybody's equipment, I recommend bringing your equalized voltage down to match absorb. I recommend EQ time of 0, just in case somebody does something crazy and pushes EQ button. And make sure you unplug your battery temperature sensors. On the Classic, you can go into main menu, into the charge menu, into TComp, and you can turn the TComp down to disabled. But I still recommend unplugging the battery temperature sensor just so they don't do any compensation. And life is good. Any ill effects if the absorb time is not observed, i.e. too long? That's kind of a tough question because, again, as pointed out earlier in the presentation, we don't want you playing in the lower and upper area of that battery. That is what wears the battery out quicker than anything. So holding it in an elevated voltage and absorb too long, you will start to see some cells doing their little cell voltage over voltage alarms internally. The battery won't shut down, but you will see that. Like if you've ever played with like an EG4 and you've had their software running, if you run an log absorb time, you'll see those cell over voltage alarms. So I would say it really depends on how often and how much, right? Like I wouldn't set it for 2 hours and leave it and let it do an absorb charge every day. If you installed the system and you forgot to change it, it's going to take you a week to get back there. No damage is going to be done until you can crank that down to 5 minutes, right? So that's kind of my take on it. When ordering a pre-wired kit, can we specify the BTS be unplugged from Rosie and the Classics? Or are they not even present? That's a really good question. I'm going to give Jeremy kudos on that one. That is something I hadn't thought of, and I will take an action on that right now. When we get done this webinar, I will make sure that when you purchase the kit, the BTSs are not included. Maybe we'll include them in a bag, but tell you not to use them. They would presently, as shipped today, if you've already ordered one of these kits, the BTSs would be plugged in, so it would be up to you to unplug them. So just keep that in mind. And I think that's about it. So we've gone well over our hour. You guys have listened to me ramble for a while now, and I really appreciate that. So if there's any other questions or any other information needed, phone number, you've got the phone number, my email, ryan@midnitesolar.com, support@midnitesolar.com. We'll get you fixed right up. No problem at all. And we will get this up online so this recorded video can be watched very soon. Sue will do that. So appreciate everybody coming out. Appreciate you taking your time out of the day, and we'll talk to you guys all later.